Here's warm-up 5.3. We're going to start by writing an equation in slope-intercept form for a line through these 2 points. So slope-intercept form is y equals mx plus b. So you got to know that's what slope-intercept form means. So I need to find the m and the b. So my answer might look like y equals 2x plus 3, something like that. Okay? So let's start by finding the m, that's the slope. And if I think of this as my first xy pair, and this can be my second xy pair, the slope formula, we're going to subtract the y's in the numerator. So I got y sub 2 minus y sub 1, and in the denominator, I subtract the x's. Okay, so let's plug those in. So I've got 5 minus negative 3 on top. Got a double negative there. On bottom, I've got negative 4 minus 2. Okay, so that on top that would become 5 plus 3, which would be 8. On bottom, negative 4 minus 2 is negative 6. And then I want to reduce that, so that's going to reduce into negative 4/3 if I divide the top and bottom by 2. Okay, so now I figured out the m part. So let's plug that into the equation. So far we've got y equals negative 4/3 x plus b. All right, and I still need to figure out what the b is. And the way I'm going to do that, I'm going to use one of the through points. It doesn't really matter which one. You could use either of these. I always just use the first of the through points. So I'm going to plug in negative 3 for y. And I'm going to plug in positive 2 for x. And now I should be able to solve this for b. So I know my answer is going to be y equals negative 4/3 x plus or minus something. And here's how I'm going to find the something. Okay. So let's see. If you multiply here, we're going to get negative 8/3. You can think of that as 2 over 1 and multiply straight across. So that would give us negative 8/3 plus b. Okay. And now I'm going to add 8/3 to both sides to isolate the b. Okay, so I've got it down to this, and what I want to do now is get a common denominator. This isn't even a fraction right now, but you could think of that as negative 3 over 1. Okay, so what I want to do with this is I want to multiply this by 3 over 3, which would give me negative 9/3. Negative 9/3 is equal to negative 3, right? So now I've got negative 9/3 plus 8/3 equals b. And now I can combine those because I have a common denominator. So that would give me, just add the numbers on the top. So negative 1/3 is my b value. So if you go back to here, remember we knew it was going to be negative y equals negative 4/3 x plus or minus something. Now we know what that something is. So final answer, I've got y equals negative 4/3 x minus 1/3. Okay, let me separate this out from the next problem a little bit. Okay, next problem, I've got a 2-column proof here. We're told that these 2 lines are parallel, and you can see that's in the picture too. Okay, and we're meant to prove that angles 1 and angle 3 are congruent. Now it's true if you use the alternate exterior angles theorem, you could do this in one step. But I'm filling in blanks here. So this is really a proof of the alternate exterior angles theorem. So let's say you didn't know the alternate exterior angles theorem. We could show that it works with these steps. Okay, so let's start working through this. So first statement says line K is parallel to line M. Well, that's the given info, right? So I'm just going to write given here. The first reason should always be the given info, okay? And then I need to figure out, well, then why is angle 1 congruent to angle 2? Why are these congruent? Well, these are corresponding angles. They're at corresponding positions in their intersections. This is at the top right of its intersection. That's at the top right of its intersection. And when these lines are parallel, I call these the tracks. When the tracks are parallel, the corresponding angles are going to be congruent. So this is the corresponding angles theorem. Okay, and then 2 and 3 are congruent. Okay, So I'm putting 2 dashes to show these are congruent. Well, I don't even need the parallel lines for that. Anytime you have two intersecting lines, the angles that are across from each other are going to be congruent. They're called vertical angles. So that's the vertical angles theorem. Okay? Now looking at the picture, the last thing we're going to do is say that these two angles are congruent. Well, 1 is congruent to 2, and 3 is congruent to 2. So I got two different things that are congruent to angle 2. That means those two things must be congruent to each other, right? If it's, two things are congruent to the same thing, they must be congruent to each other. So you could do this in two different ways. You could do this with the transitive property of congruence. Means two things are congruent to the same thing, then they're congruent to each other. So I'm just writing that as a short for property of congruence. Or you could do substitution, because you could say, hey, you can substitute, you can substitute angle 1 for angle 2 into that second statement, for example. So if you replaced this 2 with the 1, then you'd get that last one. So you could also use substitution. Okay, that's the end of the warm-up, and I'll see you next time.